The description of the moon's smell, often compared to that of gunpowder, is one of the fascinating observations shared by astronauts from the Apollo missions. Upon returning to the lunar module after their excursions on the moon's surface, astronauts noticed that the fine lunar dust adhering to their suits gave off a distinct odor reminiscent of burnt gunpowder. This intriguing phenomenon has since become a subject of scientific curiosity, with multiple theories proposed to explain its origin. Lunar dust, known as regolith, is unlike any terrestrial soil. It is a fine, powdery material resulting from billions of years of micrometeorite bombardment that pulverized the moon's surface rock into tiny jagged particles. Unlike Earth, the moon lacks both an atmosphere and water to facilitate chemical weathering or erosion, which means the dust retains sharp edges and a highly reactive surface. This fine, particulate material is primarily composed of silicate minerals, iron, and other trace elements, including those embedded through solar wind bombardment. These unique physical and chemical properties are believed to play a significant role in producing the odor. One leading theory is that the smell arises from a chemical reaction between the lunar dust and oxygen when the dust is brought into the pressurized and oxygen-rich environment of the lunar module. Over billions of years, solar wind, composed of charged particles such as hydrogen, helium, and oxygen ions, has bombarded the lunar surface. These ions become embedded within the structure of the lunar regolith, altering its chemical properties. When the dust is exposed to oxygen for the first time, something that doesn't naturally occur on the moon, it may trigger oxidation or other chemical reactions that release volatile compounds. The products of these reactions could include metallic or mineral-based volatiles that mimic the scent of gunpowder. Another consideration is the physical and tribochemical behavior of lunar dust. When the dust is handled or subjected to friction, such as during its interaction with astronauts' suits or tools, the jagged particles could break further or generate heat. This heat may release trapped ions or activate chemical processes that mimic the thermal decomposition associated with combustion. Although there is no organic material or true combustion occurring, the reactions might produce similar aromatic compounds, creating a smell that humans interpret as burnt. Additionally, the heat and pressure changes within the lunar module upon re-entry may also play a role. The vacuum of space precludes volatile compounds from dissipating, meaning that the lunar dust could carry a stored chemical state. Upon exposure to Earth-like pressures and temperatures, these chemicals could volatilize and produce a noticeable odor. This idea suggests that the smell is a product of the interplay between the unique environment of the moon and the contrasting conditions inside the spacecraft. Finally, the psychological component of olfactory perception may also influence astronauts' descriptions. Humans often associate new and unusual smells with familiar ones, leading the astronauts to describe the odor in terms of terrestrial experiences like burnt gunpowder. While their observations are crucial, understanding the exact molecular mechanisms underlying the scent remains a scientific challenge that could be clarified by future lunar missions. In summary, the gunpowder-like smell of the moon is likely a result of the unique chemical and physical properties of lunar dust, combined with its interaction with oxygen and environmental changes upon returning to the spacecraft. This phenomenon highlights the alien nature of the moon's environment and the fascinating interplay between extraterrestrial materials and Earth-like conditions.